Today, we're going to look at the problem of calculating the integral. We're given the fact that the integral from 0 to positive infinity of sine x over x is pi over 2. Given that fact, we're going to evaluate the integral of the following two functions, which is the square function and the third power. Now, for people who have background in signal processing or electrical engineering in college, this is called a sampling function or sinc function. Now, the definition usually, of course, when x equal to 0 is not defined, right? So the limit, however, goes to 1. So the typical definition is that when x is not equal to 0, it's going to be sine x over x, where x is 0, then it's 1. This is a shapeless function, it's symmetrical, right? So if you learn a Fourier transform and you know the integral of this can be calculated, and usually it's pi. By symmetrical nature, from 0 to positive infinity, that would be pi over 2. For this problem, you don't have to know how to calculate this. This is given. We're going to evaluate the square of sinc function and the integral of the cubic of the sinc function. You may want to pause the video, try to solve this problem yourself. Alright, in this problem, we're given this integral, which is sinc x, is pi over 2. We try to calculate the integral of the square of this function. Now, of course, we have the hint already, right? That is, we have to somehow use this. In other words, you need to convert this in this kind of form. How can we do that? One common trick is that whenever you see 1 over x squared, you can think that is 1 over x derivative. And then from there, you use integration by part. Let's try that. So in other words, we know that 1 over x derivative is actually equal to x negative 1 derivative equal 1 over x squared. With this, we can say this is actually equal, for this x squared, we're going to treat it as sine square x, right? Negative 1 times derivative of 1 over x. The integration by part for the u dv is going to equal uv minus v du. So here, what we have is it's going to be negative sine square x and times 1 over x, right? Here's this u and minus v, which is 1 over x, and then du, right? The u here, what is the u here? U is negative sine square x. So if you do the du, it's going to be equal to 2 negative here sine x and then cosine x. That's equal to sine 2x. That is sine 2x dx. Now, for the first part, we need to argue that is actually vanish. This is bounded, and this goes to 0. Closing to 0, sine x over x next to 1, but sine x would be 0. So the first term vanish, negative. There is a minus minus, right? So this is a plus. Integral from 0 to positive infinity, sine 2x and over x. But we have sine x over x, right? This is 2. So you're going to use change of variable again. If you times 2, yeah, and here you do this, right? So this 2 would cancel. 0 to positive, and then sine u over u du. If we use change of variable here, u equal 2x change of variable, right? So in other words, this also equal to pi over 2. So that's surprising results. We use this fact of the integral of sinc function, we derive the results that the integral of the square of the sinc function is also pi over 2. Now we try to calculate the integral of the cubes. the third power over x to the third. Let's call this integral I. So it's useful for us to use this trig identity, that is sine 3x equals 3 sine x minus 4 sine x to the third power. Sine x to the third power is going to equal 1/4 3 sine x and minus sine 3x. Just like in earlier, we don't want to deal with this term here. So we would like to treat this as derivative of something. Of course, we know that for 1 over x squared, in other words, that is x to negative 2's power, if we take the derivative here, it's going to equal negative 2, 1 over x to the third. So this gives us a hint. For this I, we're going to use integral by parts again. So I, the integral here, we can treat this as sine x to the third power, and here we can say this is the negative 1/2 of d 1 over x squared. So that's again, we use integral by part. That is the formula. Again, let's review that. Is going to be u dv is going to be uv minus integral of the v du. Here, this is our v here. This whole thing is our u here. So let's write it down. So that's equal to negative 1/2 of sine third power over x squared from 0 to positive infinity minus the integral here is going to be from 0 to positive infinity, and that's going to be v, which is 1 over x squared, and u here we want to say du. So here we're going to use this trig identity here, but we say what's the du here? So du here is going to be, we take a derivative, is going to be 4, this is going to be 3 cosine x minus 3 cosine 3x. So here the coefficient is negative 1/2. Negative become positive 1/2. And here we're going to say 1/4 and 3 cosine x minus 3 cosine 3x and then dx. We're going to argue that the first term vanishes. 4, 3 here, that's 1/2. So that is going to be 3 over 8. So x squared cosine x minus cosine 3x dx. Now earlier we have two results, which is sine x over x and sine square x over x squared. But here we have x squared but have cosine x. Now here we're going to use another trick. So we're going to use another fact, which is for cosine alpha, we can change that to sine by using the double angle formula here, which is sine square alpha over 2. To replace cosine x minus cosine 3x by sine square, right? So it's going to be 1 minus 2 sine square x over 2 minus 1 minus 2 sine square. That's going to be 3x over 2. 1 and 1 cancel. That's going to be, negative. We're going to switch the order. So 2 sine square 3x over 2 minus sine square x over 2. So the integral here, right? So this is going to be x squared here. And that's going to be sine square 3x over 2. So minus sine square x over 2 and dx. Now that's good. So we can somehow, through some algebra multiplication, we can use these results earlier. So how are we going to do that? So we're going to split into two integrals, 3a, and then the first part is sine square 3x over 2, and then x squared dx, and then minus 4 sine square x over 2, and then x squared dx. The integral a, this integral b, so it's a minus b. So how do we calculate a? We're going to use change of variables. Here's the integral here. Now we're going to use change of variable with t equals 3x over 2. So this is going to be sine square, we're going to say t And here, x squared, we're going to change to 3x over 2 squared. Of course, you have to compensate this 9 over 4, going to be 4 over 9, right? And then for the dx, we're going to change, because we need 3x over 2. Of course, in order to compensate that, you have to time this is going to be 2 over 3. What we have is 0, and this is going to be sine squared t over t squared, and this is going to be dt, but there's extra constant. The constant here is going to be and this part. So that's, in other words, that's 2 over 3, and then you flip over 9 over 4, that's going to be 3, that's going to be 2, 3 over 2, okay? So it's going to be 3 over 2 up front. And this integral, earlier we know that is equal pi over 2. So this 3 over 2 pi over 2. That's going to be 3 pi over 4. Now for the second part, you can use similar approach. Here we're going to use change of variable. That is, you're going to try to say v equal x over 2. And I skip the steps, but you can figure it out. The integral is going to be pi over 4. The I for integral of the third power of sinc function is 3 over 8. Wait, earlier I think I'm missing a coefficient here. Oh yes, there's a 2 here. So sorry, earlier I think there was a mistake. We're missing a factor of 2. So this is going to be, there's a factor of 2. Okay, so which means this should be times 2, 3/4. So that is 3/4 a minus b. I is going to be 3/4 a, 3 pi over 4, b, pi over 4. So that's going to be pi over 2. So 3/4 pi over 2. So 3 pi over 8. So what we get is the integral from 0 to positive infinity of sine third power over x to the third power. That integral is equal 3 pi over 8. Hope you enjoyed the video. Please like, share, and subscribe to the channel.